Math Morning, Mr. Jerk is back at it again. Today we're doing Exponent Rules. In the last video, we learned how to expand and condense exponents. Now I'm going to show you some rules. There's some shortcuts that are really going to help you out. You might get mad at me and say, why didn't you teach me that last time? This is much easier. Well, I didn't. This is going to be easier. You're going to love it. And you're going to love me too. So first one, product rule, right? We could expand this out like we did in the last video. So 2 to the third power is 2 times 2 times 2. If we multiply that by 2 to the fourth power, that's times 2 times 2 times 2 times 2. And how many do I have? 1, 2, 3, 4, 5, 6, 7. So that really equals 2 to the seventh power. The shortcut, right, if you look at it, I don't have to do all this expanding. I can just look at this 3 and the 4 and add them together. 3 plus 4 is 7. So that's the product rule. If you're multiplying exponents that have the same base, you can just add the exponents and keep the same base. All right, you could pause the video, copy that down, and let's do some examples now. So we got 8 to the fifth times 3 to the third. All right, so the base is going to be 8, and then I take the exponents 5 and 3. 5 plus 3 is 8. That's an ugly 8. Circle that, and that is an 8. 8 to the 8th power. Over here we have y to the 9th times y. Well, I know if there's no exponent, is really a 1, so y to the first power. So if I add 9 and 1 together, it becomes y to the 10th power. Over here, these ones, they all have a, right? I could expand those all out and do a times a times a times a. Or I can just look at the exponents. 4 plus 3 is 7, plus 10, 17. And the last one. Over here, so 2 and 3, they don't have the same base. They're different numbers, but we're multiplying them, so I can just do 2 times 3, which is 6. And then the x's, those have the same base. X to the fourth, x to the fifth, that's going to be x to the 9th. 4 plus 5 is 9.
Let's go! Yeah! Go, baby! Gotta get deep! Gotta get deep! Yeah! Gotta put your mind to it! Go! Yeah! Go! Go! Yeah!
That was my man Ronnie Coleman bringing us to the power rule. See what I did there? Power. Power. All right, so power, that's when you have an exponent raised to another exponent. If you remember this one, we set them up like this. We said, okay, 2 to the third power. So that's 2 times 2 times 2 to the fourth power. So this is being multiplied by itself 4 times. So I have to go times 2 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 times 2. Whew, all of that stuff. And if I add them all together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is really 2 to the 12th power. Is there an easier way? There is. We got this 3 and the 4. Well, 3 times 4 is 12, right? You just multiply them together. So the power rule, when you take a power to a power, you multiply the exponents, right? So you don't have to do this whole expansion. You can just multiply 3 times 4 and get 12. Perfect. Let's do some examples. So first one, 7 to the fourth power raised to the third power. Easy, we got 7. And the 4 and the 3, 4 times 3, 12. Bam, done. Over here, we've got x, 5, x to the 5th squared. So 5 times 2, 10. Easy so far, much easier than expanding them out. Over here, oh, I got a negative 10. Huh. Well, let me do this x first. So I know we have x to the 6th squared. So 6 times 2 is 12. But what do I do with this negative 10? So down here it says treat the numbers just like numbers, right? You need to square everything on the inside, not just the x to the 6th. You need to, whatever exponent is out here, you need to multiply it or treat it just like the number in the inside. So this is going to be negative 10 squared. Negative 10 squared, right? If you do this in a calculator, remember to put those parentheses in there. So what is negative 10 squared? Well, negative 10 times negative 10, that's going to be 100. All right, and then I have x to the 12th power. So the product rule, you treat the numbers just like numbers, right? You multiply this 6 times 2, but then you just make it negative 10 squared. All right, over here, same rules apply. So this is going to be 1/3 squared, and then this x doesn't have an exponent, but it really does. It has a 1. 1 times 2 is just 2, so that becomes x squared. Y to the 3rd power, 3 times 2 is 6. All right, so I've got all that. Now I need to simplify this old fraction right there. So 1/3 squared. Well, that's going to be 1/3 times 1/3, right? When you square something, you multiply it by itself. And then I have x squared, y to the 6. All right, all right. So now I'm multiplying these fractions. 1 times 1 is 1. 3 times 3 is 9. So I have 1/9 x squared, y to the 6th power. Bam, done. So now we're talking about quotient. If you remember, this means divide. In the last video, I made you write these all out. So I said 2 to the 5th power. Well, that's 2 times 2 times 2 times 2 times 2. Divided by 2 to the 3rd power, that's 2 times 2 times 2. And then we canceled things out. So I said, okay, we got wham, bam, pow, boom, bam, bam. And then I have 2 times 2, which is 4, or you can say 2 to the 2nd power. Is there a rule for this? Yeah, right? We got a 5 there and a 3 there. Well, 5 minus 3 equals 2. So the rule is when you divide exponents with the same base, you subtract the exponents. All right, so the same base was 2, and then you subtracted 5 minus 3 is 2. So pause this video, copy that down. Now let's do some examples. So first thing you want to do, check, is the base the same, right? 2 and 2, yep, we're good. Now, I just subtract the exponents. We have 11 minus 6, oh, that's 5, right? So that's 2 to the 5th power. The base in this one is negative 4. All right, so I can write negative 4, 7 minus 4, that's going to be 3. Negative 4 to the 3rd power. Over here, the base is x. So 5 minus 3, right, that's going to be x to the 2nd power, or x squared. All right, let's do some more complicated ones. Whew. We got some numbers and letters. So 3 and 12, are those the same base? No, but I can simplify this fraction. I can divide them both by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. So I can really say 1/4. And then I do the y's, right? They have the same base. 11 minus 5 is 6. So that's 1/4 y to the 6th power. Or, if you want to get fancy, you can say y to the 6th divided by 4. All right, over here, same deal. The 6 and the 2, that's not the same number, but they can both be divided by 2, right? So 6 divided by 2, I'll cancel that and write 3. 2 divided by 2 is 1. So 3 divided by 1, that's really just 3. And then I'll do the rest of these variables. So 9, or x to the ninth, x, this is really x to the first power, right? So 9 minus 1 is 8. So that's x to the eighth power. And then y to the fourth minus y squared, or divided by, we have y, 4 minus 2 is 2. And then lastly, we have a z. Z to the fifth minus z to the fourth is really z to the first power, or just z. So there we go. Bam, done. So here are some more examples just to give you some more practice. So we have 2/3 to the third power. If you remember, that's going to be 2/3 times 2/3 times 2/3, and that equals 2 times 2 times 2 is 6, or I can say 2 to the third power. 3 times 3 is 9, times 3 is 27, or 3 to the third power. I think I said this was 6, 2 times 2 is 4, times 2 is 8, so my bad. So there we go, or the shortcut, right? The power rule, you have to do it to the top and the bottom of the fraction. So 2 to the third power is 2 cubed, 3 to the third power, 3 cubed. You need to do it to the top and the bottom. Like this one over here, x to the third, right? I just write x to the third. And then I have to do the bottom of the fraction to the denominator. That becomes y to the third power. All right, over here, same thing. But when I do it to the top, I need to do it to the 2 and the x. So this becomes 2 to the third power, x to the third power. And then on the bottom, I need to do that as well. Y, 2 times 3, that's going to be y to the sixth power. All right, now we're going to have a little flashback. Let's see. Ooh, GEMDAS is awesome. Do you guys remember this? GEMDAS. So the G, that stands for grouping symbols. The E, that's for exponents. Multiply, divide. So we got multiply, divide, and then add, subtract. So that's how you do the order of operations. Why am I showing you this now? I'm going to show you, right? We have all these rules. This is a nice way to remember them. So, for example, let me change the color. If you had one of these with an exponent, if you had 2 to the third power to the fourth power, what do I do? Do I add that, multiply, divide? I don't know. Well, if you look over here, you have exponent. Right below that, you have the m for multiply. So that means you're going to multiply. So this becomes 2. 3 to the fourth power is 12. So I multiplied those two. All right, let me change my color, do another one. So what if I had this? If I had 3 to the second power times 3 to the fifth power. All right, what do I do with that? Well, this is being multiplied, so I find multiply. I go below it, and it's add. So I need to add those together. So that's 3, 2 times 5, or 2 plus 5 is 7. I think you see where I'm going with this last one too. Let me make it purple. So what if I was, if I had 4 to the 10th power divided by 4 to the 8th power? What would I do there? Well, I got divide right there, and below that is subtract. So I subtract the exponents. So I still have 4. 10 minus 8 is 2. So you can always write this down to help you remember those rules. Genius. Genius. Let's do some more examples. So what do we got here? 5y to the third power times 6y to the seventh power. So we're multiplying. There's the m. So what are we going to do with the exponents? We're going to add them. So the 5 and the 6, well, they're not the same base, so I just do regular multiply, 30. And then y, they have the same base. We said we're going to add them. 3 plus 7 is 10. Done. I'm moving on. Oh, one more kitty. All right. So here we go. What do we got? We got 4x to the fifth power, y to the third power, and all that is brought up to the fourth power. So that's an exponent. I'm going to circle the old exponent and multiply. So I gotta, multiply everything on the inside by this exponent. So it becomes 4 to the fourth power, right? Treat that like a number. Then x to the fifth power times 4. So that's going to be x to the 20th. And lastly, y to the third power, 3 times 4 is 12. Bam, just like that. You can leave it like this, or for the fourth power, that becomes 256, x to the 20th, y to the 12th. All right, one more. Oh, one more kitty too. What do we got here? So this is being divided, 5a to the 8th power, b to the 5th power, divided by 7a to the 5th power, b to the 3rd power. So when you're dividing, we're going to subtract the exponents. So first I look at these numbers. Well, I can't really reduce them, so I'm just going to write it again. 5/7. And now I had to subtract the exponents that have matching bases. So a, 8 minus 5 is 3. And then b, 5 minus 3 is 2. Voila, done. Bam. All right, last one, and we are bringing the pain. So we've got this big monster over here. How are we going to do it? Well, we can just use GEMDAS, right? Do I have a grouping symbol? Yep. Do they have exponent? Well, that one does. So let me do the exponent first. So this right here, I've got this 3. I'm going to do everything on the inside of these parentheses. So 2 to the 3rd power, that becomes 2 to the 3rd power. A, oh, and what am I doing here, right? If there's an exponent, I'm going to multiply. So a to the 3rd power, so 3 times 3, it's going to be 9. And then b to the 4th power, 4 times 3 is 12. All right, so I got that right there. Perfect. Over here, there is no exponent. It's really a 1. But I can just write that out. 4ab to the 5th power. All right, so I just did my exponent. Awesome. Now, what should I do next? So, GM, multiply. Yeah, let me multiply some stuff. I got to multiply right there. I'll multiply. So, well, before I do that, 2 to the 3rd power, 2 times 2 is 4. 4 times 2 is 8. So this is really 8, a to the 9th, b to the 12th times 4ab to the 5th. All right, so now when I multiply these out, 8 times 4, that's 32. A to the 9th times a, that's really a to the 1st power. So 9 plus 1 is 10, so that's a to the 10th. B, let's see here, b to the 12th times b to the 5th. I'm going to add those together, right? I didn't circle this, but when you multiply, you add, right? Multiply and add. So b, 12 plus 5 is 17. Bam. So the top, that's simplified. What should I do next? What should I do next? How about divide? Right, I didn't divide anything yet. So I'm going to write the bottom, 64, a to the 5th, b to the 3rd, right? That's divide and subtract. So remember that came from right there. This is the top part. So let me divide, and when I divide, I'm subtracting the exponents. So first, I've got 32 and 64. They're different bases, but can I simplify these? Yeah. 32 goes in 32 one time. 32 goes in 64 two times. So this is really 1/2. Now we've got the exponents, right, and the bases. So these both have a base of a. 10 minus 5 is 5. Now I've got the b's. Remember, my rule is subtract. If I'm dividing, I'm subtracting. So b, 17 minus 3 is going to be 14. Voila. Whew. We brought the pain. We did it. So now it's up to you to do the mastery check, to do the packet. You've got this. Dirkus out.